Hi everyone, welcome to our hydraulics laboratory, where fluid mechanics comes to life.
I am Dayan.
I'm Christian.
I am Sherilyn.
And I am Angel.
Familiar, you're familiar. So if you don't know by now, then you should probably get familiar. So if you don't know by now, then you should probably get familiar. Just give her.
Hello guys! Welcome to our another laboratory experiment, fluid flow in Weirs. So here's how we did the procedure for each trial during our experiment using the rectangular and contracted weirs. Let's start with the rectangular weir. This type of weir has a flat crest and it spans straight across the channel. Wala siyang contraction sa side, so buong width ng weir ay ginagamit ng tubig to flow over. For the first trial, we set the flow rate to 500 liters per hour using the control valve. After that, hinintay muna namin na mag-stabilize yung flow, meaning steady na yung tubig and walang sudden changes. Then we measured the head or yung taas ng tubig above the weir crest.
Okay na? Baliktad, babe. Baliktad yung mga.
For the second trial, we increased the flow to 1,000 liters per hour. We did the same procedure, stabilize the flow, then measure the head. We notice na mas tumataas na yung tubig above the crest. This is because mas maraming tubig na yung dumadaan, so naturally, the height increases para makatawid sa weir. Ilan?
1.2.
Yung kanina, 0.9.
Ay, hindi.
Ilan? Finally, for the third trial, we set the flow to 1,500 liters per hour, which is our maximum flow in this experiment.
Patay ka. Patay ka. Gusto mo yun ito. Pila. Kapal na mo. Ha?
Again, after letting the flow stabilize, we measured the head.
Huwag mo yun na pinag-iipat ka to ha.
At this point, mas naging obvious yung flow over the weir. Mas mataas yung head and we could see a more turbulent nappe or water sheet flowing over the weir. This confirms that head increases as flow rate increases, which is exactly what the theory tells us. Baba pa konti. Taas mo konti. Now let's talk about the contracted weir. This one is a bit different. Instead of covering the full width of the channel, it is narrower, and there's a space between the sides of the weir and the walls of the flume. That's why it is called a two-end contracted weir. So for the trial one, just like with the rectangular weir, we started at 500 liters per hour. Once the flow was stable, we measured the head. Right away, we noticed na mas mataas yung head compared to the rectangular weir, even though same lang yung flow rate. This shows the effect of contraction. The narrower opening means water needs more pressure or height to flow over. Angat mo, be. Angat mo. Buti tita ka, angat mo pa.
Kita ba? Anyway.
Hindi, be, pag pinatong mo, nakaano lang yung zero eh. Sige, sige, ano mo. Dito ko tatanda. Angat mo, be. Angat mo pa. Yan. One point five. Sakto na to, no? Again, for the trial 2, we increased the flow to 1,000 liters per hour. After stabilizing the flow, we again measured the head. Angat pa. Yan. At this point, mas kapansin-pansin na yung difference. The water level above the crest is even higher than what we saw with the rectangular weir at the same flow rate. Neto lang. 2.2? 1.5 yung kanina, 2.2 yung ngayon. For our last trial, we set the flow to 1,500 liters per hour. Again, stabilize the flow, then measure the head. This time, napansin namin na mas mabilis umangat yung water level, and the head was significantly higher than the previous trials. The water sheet flowing over the weir or the nap was thinner but more forceful. This makes sense kasi with the contracted weir, the opening is more limited. 2.8. Out na. So, after completing all the trials and comparing the two types of weirs, here is what we can conclude. First, both the rectangular weir and the contracted weir are effective tools for measuring flow rate in open channels. They work by relating the water height or head above the crest to the actual discharge. Second, even though we use the same flow rates in all three trials, 500, 1,000, and 1,500 liters per hour, the head was consistently higher in the contracted weir compared to the rectangular one. This is because the contracted weir has reduced flow width, so the water needs to rise higher to pass over it. Third, as the flow rate increased, the difference in head between the two weirs became more noticeable. This shows that the weir geometry plays a big role in how water flows and in how we measure that flow accurately.